Welcome to the Ultimate Fiber Optics Challenge. Think you know everything about fiber optics technology? Now is your chance to prove it. In this quiz, we'll test your knowledge with 20 basic questions in fiber optics. So grab a pen, get ready, and see how well you can do. Be patient and stick with it until the end. You'll get the chance to see every question from the simplest to the most challenging. 1. Which of the following best describes single-mode fiber? A. Supports multiple light paths simultaneously. B. Has a larger core diameter, 50 to 62.5 microns. C. Supports only one propagation mode. D. Primarily used for short-distance LAN applications. The correct answer is C. Single-mode fiber supports only one propagation mode. 2. What is the typical core diameter of single-mode fiber? A. 9 microns. B. 50 microns. C. 62.5 microns. D. 125 microns. The correct answer is A. The core size of a single-mode fiber ranges from about 8 to 10 microns. 3. Total internal reflection in fiber optics occurs when A. Light moves from low to high refractive index. B. Light strikes the core cladding boundary below the critical angle. C. Light strikes the core cladding boundary above the critical angle. D. Light passes directly through the cladding. The correct answer is C. Total internal reflection occurs when light traverses the core cladding interface above the critical angle. 4. The core of an optical fiber has a higher refractive index than the cladding in order to A. Minimize attenuation. B. Ensure total internal reflection. C. Reduce modal dispersion. D. Increase fiber tensile strength. The correct answer is B. The index of the core should be larger than that of the cladding for total internal reflection to occur. 5. What is the main advantage of graded index multimode fiber over step index? A. Supports longer single-mode transmission. B. Reduces modal dispersion. C. Lower cost to manufacture. D. Easier splicing. The correct answer is B. The graded index profile helps reduce modal dispersion. 6. Which of the following is a primary cause of fiber attenuation? A. Mechanical splicing. B. Rayleigh scattering of light in the glass. C. Chromatic dispersion. D. Mode field diameter mismatch. The correct answer is B. Rayleigh scattering of light in glass is the main cause of attenuation. 7. Which type of dispersion occurs only in multimode fiber? A. Chromatic dispersion. B. Polarization mode dispersion, PMD. C. Modal dispersion. D. Waveguide dispersion. The correct answer is C. Modal dispersion occurs only in multimode fiber. 8. Which fiber type is optimized for bend-insensitive single-mode operation? A. OM3. B. G.657. C. OM5. D. G.652. The correct answer is B. G.657 is optimized for bend-insensitive single-mode operation. 9. The mode field diameter, MFD, is used to describe A. The physical core diameter, B. The effective area over which light propagates in single-mode fiber. C. The diameter of the cladding. D. The bandwidth of multimode fiber. The correct answer is B. MFD is used to describe the effective area over which light propagates in single-mode optical fiber. 10. The cutoff wavelength in single-mode fiber refers to A. The wavelength below which multimode propagation occurs. B. The wavelength with the lowest attenuation. C. The wavelength above which fiber breaks. D. The wavelength for optimal splicing. The correct answer is A. Cutoff wavelength is the wavelength below which multimode propagation occurs. 11. Which of the following affects fiber splicing and connector performance? A. Ovality and core clad concentricity. B. Fiber jacket color. C. Primary coating hardness. D. Proof test stress. The correct answer is A. Ovality and core clad concentricity affect splice and connector performance. 12. What is the primary function of the secondary fiber coating? A. Protects fiber from mechanical damage. B. Guides the light through the core. C. Maintains total internal reflection. D. Reduces modal dispersion. The correct answer is A. The primary function of the secondary coating is to protect the fiber from mechanical damage. 13. Proof testing of optical fiber is used to A. Measure attenuation. B. Confirm mechanical strength. C. Measure refractive index. D. Reduce chromatic dispersion. The correct answer is B. Proof testing is used to confirm fiber mechanical strength. 14. Which of the following fibers can generally be spliced together with minimal loss? A. Single mode with multimode fiber. B. G.652 with G.657A fiber. C. OM3 with single mode fiber. D. OM4 with G.652 fiber. The correct answer is B. G.G52 and G.657A fiber can be spliced together with minimal loss because they are compatible. 15. OTDRs rely on which of the following principles to detect fiber faults? A. Raman scattering. B. Rayleigh backscattering. C. Chromatic dispersion. D. Modal coupling. The correct answer is B. OTDRs use Rayleigh backscattering to detect faults. 16. The zero dispersion wavelength of standard single-mode fiber is approximately A. 850 nanometers, B. 1310 nanometers, C. 1550 nanometers, D. 1625 nanometers. The correct answer is B. 1310 nanometers. 17. Macro bending loss is caused by A. Small-scale imperfections in the fiber. B. Large radius bends in the fiber. C. Refractive index fluctuations. D. Attenuation due to Rayleigh scattering. The correct answer is B. Large radius bends cause macro bending loss in fiber. 18. What is the typical bandwidth of OM5 multimode fiber at 850 nanometers? A. 200 megahertz kilometer. B. 1500 megahertz kilometer. C. 100 megahertz kilometer. D. 4700 megahertz kilometer. The correct answer is D. The typical bandwidth OM5 at 850 nanometers is 4700 megahertz kilometer. 19. Which of the following is an example of a nonlinear fiber impairment? A. Chromatic dispersion. B. Four-wave mixing. C. Rayleigh scattering. D. Macro bending loss. The correct answer is B. Four-wave mixing is a nonlinear fiber impairment. 20. What does 0 dBm correspond to in milliwatts? A. 0 milliwatts. B. 0.1 milliwatts. C. 10 milliwatts. D. 1 milliwatt. The correct answer is D. 1 milliwatt corresponds to 0 dBm. Great job completing the quiz. If you scored at least 12 questions correctly, you've got a strong foundation in fiber optic fundamentals. Take your knowledge to the next level by exploring optical technology training's certification programs delivered by Fiber Guide. Check the Fiber Guide course schedule to see upcoming class dates. Don't forget to subscribe and hit the notification bell so you never miss a new video. Let us know in the comments what you thought of the quiz and whether you'd like more quizzes on topics like fiber cabling, termination, optical amplifiers, transceivers, and more. Thanks for watching and see you in the next one.